All right. So today we're gonna be doing chapter 7. I'm gonna start with electromagnetic radiation and then move into what is it? What's it called? The Bohr atomic theory for hydrogen atom and their shells. All right. So just to recap, what does this symbol mean?
Oh, it's frequency.
Mm-mm.
Oh, it's like I'm sorry. Wavelength.
Wavelength, yes. And what's the formula for the wavelength?
Velocity over frequency.
The formula, not to find wavelength, the formula of wavelength.
Sorry about that. I'll be back too.
I can't hear you, Henderson. You're cutting off.
Can you hear me now?
Yeah, I can hear you now.
Sorry about the loud noise. Like I said, I'll be back in 2 minutes.
Okay, no worries. The wavelength measure unit, what would it be?
Oh, it's cycle over second.
No.
And then cycle over centimeter.
Centimeter over cycle.
Oh. I have to study that.
You can write it. This is the formula for it.
Okay.
But but in the after the calculation, it comes out like this.
Oh,
Cm
okay.
-1.
All right, I got it.
Or 1 over centimeter. Which means the same thing. It's just the one is on top or the one is here.
Got it.
So that's the formula. That's the measure unit for wavelength.
Mm-hmm.
All right. And this one, what is this?
That's frequency.
That's frequency.
Yes, frequency. And measure unit for frequency?
Cycle over second.
Cycle over second, yes. When you do the calculations, the cycle comes out, and all you're left with is with the second.
Mommy, get the chocolate.
Also known as
Cycle.
1 over S. You know what a cycle is, right?
No.
Okay. Let me draw it out. This is considered one cycle.
Okay.
Because you know a cycle is a circle, right? So that's pretty much what it is. But instead of going in the, that's technically what's happening. This is what's in the, this is what you see in the middle right now. This line here. This line here is this dot right here. So we're looking at through the tube now. We're looking at like down straight path.
Okay.
And the wave is traveling in a cycle spiral. But sideways, it just looks like it's going up and down. So this is the sideways view. And this is looking at like through the tunnel. It's going spiral.
Okay.
So that's what I mean by cycle, because when you're spiraling, one cycle, two cycle, like that. Sideways, it just goes up and down. So that's what a cycle means. So it's traveling by per second.
So do we have a
It's just to understand how the cycle works.
yeah, but cycle, is he trying to, there's a number for a constant for cycle?
For the notes that he wrote on the thing, that's all I see, and in my notes, that's all I see. He
So it
didn't.
doesn't have like a constant number, like let's say like the speed of sound is 3.10. It doesn't have that.
No, that's when you're trying to get the calculations. That's the formula for it, for frequency. Like to calculate the frequency of a cycle.
Oh, you mean that the unit or the formula?
Yes, to find this thing by itself.
Okay.
And 1 second, it's also considered as 1 hertz.
Okay.
That's all pretty much what electromagnetic radiation is. But I want you guys to give me the definition of them. So EMR, what's the definition?
It has an electric field compound and a magnetic field.
Radiation, the radiation. That's wave.
The emission or transmission of energy in the electromagnetic waves.
Hold on. I don't know why I didn't want to copy that. Okay, so it wants to give me problem right now. Also known as I realized in the end what it meant, it just meant light waves. That's what it means. It just means light waves.
Okay.
Now, what's the definition of electromagnetic wave? I'm not even typing. What's the definition?
No.
Oh my God, hold on. So the wave is just basically an electric field component and a magnetic field component. The radiation is the emission and transmission of energy in the form of electromagnetic wave, also known as light waves. One is electromagnetic and one is light waves. So I have a bonus question here. I know you guys don't, he didn't ask you this, but I want to know if you guys understand this. What is a photon?
It's when the electron leaves the orbit of the it's of the electron leaving the field. I know this. I just read this.
Light particle.
Exactly.
So this is considered an electromagnetic wave. But if it's coming from here, let me see if I can draw this. I'm not a good artist, so I'm gonna draw something right now. So trying to draw this and this. I consider this as a flashlight, poorly drawn flashlight. This here that's producing the light, that's considered the EMR, the electromagnetic radiation. The thing itself is a wave, the electromagnetic wave. What's passing with the light, these are the photons, the little particles. That's what those means. The whole thing is the electromagnetic wave. When it's coming from the light, it's considered the EMR, and the little particles emitting from the light is called a photon.
Proton?
Photon.
P-H-O?
Mm-hmm.
Okay.
This is just bonus information I'm just giving you so you can learn what the particle is, how this thing works.
Okay.
It's not going to be on the test. All right, so let me throw you some problems. Now, how do we get C?
Frequency.
Frequency,
Wavelength?
that? Yeah, that's technically the correct answer because when you multiply, it doesn't matter the order. But it's really just wavelength times frequency.
Okay.
And when we find lambda, what's the formula?
It's velocity over frequency.
Mm-hmm. D is another word for velocity, just letting you know, Henderson.
Gaudio.
And how do we get frequency? What's the formula for frequency?
Velocity over wavelength.
Yep. That's it. That's all. That's pretty much chapter 7.12. That's all. Any questions on this before I move on?
No.
All right, so moving on to my favorite section. I'm only going to cover the parts where he wants us to know.
Yeah.
So how I put it here. I don't know why you're not copying it. Bohr theories of hydrogen atom and their shells. So the main thing that's just dealing with is dealing with the one of the 4 quantum numbers. You guys know the quantum numbers, right? What are they?
Yeah.
N, L, M, L, M, S.
N, L, M, L, and
M-
MS. Yeah. But this one here, this part here is only dealing with this part, the N.
Okay.
So what is the N?
What you say?
What is the N called?
Oh, principal quantum?
Yep. Definition?
The shell level?
Right, that's what I explained to you, but according to this, it's more than just the shell level, but I want the textbook definition.
I don't get it.
That's the definition. One of the 3 quantum numbers used to characterize an orbital. But when it comes to this theory, as I said, yes, it is the shell level. That is correct. But when this is more the shell energy level. When it comes to his theory. So this is extra. This is the new material I'm showing you.
Can you
So
say one more time?
it's now called the shell energy level.
And the
For
quantum
N.
number?
For N.
Okay.
It's shell energy level. Yesterday I explained it as the regular level, but because we're doing this part here, the theory of the hydrogen atom, they're calling it the shell energy level. So I'm gonna draw the image. Where would N1 be?
Close to the nucleus.
The first level.
Oh,
Right
the proton,
Yeah.
here. N1.
Yeah.
And this would be N2. This would be N3. And the outer shell will be N4. And it gets bigger and bigger and bigger. So each shell has their own energy level. This here is the energy level. Oh, this is energy inside here. So the reason of Bohr's theory for a hydrogen atom in their shells, he had 4 components, and I'm going to write them here. These are the four functions of his theory. One, it's he found out there's spherical quantized orbitals. The orbitals, as you see, they're all spherical, circle. In 3D, there's like globe, spherical. Number two, he found out there's quantized radius, also known as radii. The unit for that is r. So radius is pretty much this. From here to here. From here to here. From here to here. Okay. Thank you. From here to here. And from there to there. The first line would be R1. The second line would be R2. And the third line would be R3. R1 because it's touching the first shell. R2 is because it's stuck in the second shell. R3 because it's stuck in the third shell. So what would this one be?
R4.
R4, right, because it's touching the fourth shell.
So basically, looking at it, this picture, we're looking down through the whole of the.
This is a 2D image.
Yeah.
This is just a 2D image of the atom. So in 3D,
Okay.
It's pretty much like, see it as how the core is Earth.
Yes.
This is the core of the Earth.
Yeah.
This is the first mantle, the second mantle, all that other stuff. I don't know the names. I forgot their names. But yes, just like that.
Yes. Okay.
So the energy inside that shell, which is that whole orbit inside here, the radius is only from from the center to the end of the energy level of the first shell. That's considered the radius, the distance. And number three, quantized energy, that's what I'm talking about. This is the quantized energy, without the color that I was just drawing. This is the quantized energy inside each shell. So continuing the pattern, inside will be what? The unit is E. So inside will be what?
E4. On which level?
Inside the middle.
E1.
E1.
E1. Right. And the second one?
E2.
E2.
E2. And it goes on like that. E3. E3, energy level 3. And the last shell, energy level 4. The fourth function is electron gives off light when they move from the outer orbit to inner orbit, or going from the outer shell to inner shell. So an electron, I'm gonna choose this color here. An electron that's on this shell, third shell, moves on to this one. It's gonna produce more light as you get closer to the center. So those are the four functions of the theory. So review question. If I have an electron on the first level and I jump to the third level, am I giving more light or am I losing more light?
You're losing more light.
I'm losing more light, right?
Why?
Because if you're going from inner to outer, you lose in light. But if you're going from outer to inner, you show more light. Correct?
Oh, okay.
Right. But at the same time, if you want to see more the technicality, you know what's in the center of the atom, right?
Oh, let's make some more fire. Let's do this. Let's get more
You
fire.
don't remember what's in the center of the atom?
No.
The protons, the plus charges.
Okay.
So what does it what does a plus need to what does it attract?
What do you mean?
What does it attract?
Hmm.
The protons, what does it attract?
Electrons.
Electrons, because they're negative.
Okay.
So this here, this electron, the closer it gets to this to the nucleus, the proton, it's gonna give off more energy. The farther it goes away, it's gonna give off less energy, less light.
Okay. Got
You're
it.
farther away from the proton. So that's the technicality of it. But hey, guess what? There's more formulas.
Yay.
Formulas. We gotta love these formulas. There's formulas to get the R and there's formulas to get the E.
Is it possible we could do one example with each and one of them to see how it pans out? See how it comes out.
Right. I'm gonna show you the formula, but first, before I go to that formula, I want you guys to know this symbol.
All right, no problem. Thank you.
Actually, I'm just gonna draw it. This symbol here. Where did the mouse go? You guys know what this symbol means?
No.
On the review sheet, proportional.
It means proportional, right? So it's not equal to, it's proportional to.
Oh, okay.
So the formula for R is this. I'm gonna write it here. Actually, it's gonna be, I'm just gonna write it here. Much better. It's R n proportional to n squared. That's the formula to get radius. You use this to calculate how big the ring is going to be, how big the radius of the atom is going to be. So since you know this formula, now I'm going to just give you the numbers to plug it in. If n is 1, then you plug it into the formula R1, because n is 1, proportional, 1 squared.
Mhm.
This is also known as a subatomic unit. So this is the subatomic unit for the radius for the first shell. All right, so I gave you that example. So I'm going to give you a number and I want you to give me how it will look in proportion. Okay?
Okay.
So the n is n5. I'm gonna start you off. R. What goes here?
5
R5.
proportional
Proportional.
to 25.
Right. 5 squared or 25. So what did that tell you about the N5 ring?
It's 25 rings.
No, it's gonna be huge.
Yeah, it's gonna be huge.
That's what it just means. So the bigger the number, the bigger the ring. That's just pretty much what it is telling you.
Okay.
It's gonna be huge. So each ring is squared from the previous ring. So that's how bigger it's gonna get. So N4 is what?
L4
R4.
proportional to 16.
Right. So that's how you can tell the ring is smaller than this one.
Okay.
But it's not double size. That's the thing. It's not double size. So when you use this formula, that's the only way you can tell for the radius. It's going to be bigger or smaller. And that's the R. That's the quantized radius. That's for R. Questions? No questions before I move on?
No question.
Okay. So I'm going to do E now. E also has a formula. What is E again?
Oh, the quantized energy.
That the shell is giving off, yes. So this is the formula for E. So the pattern repeats as well, just like the N. Just like the R. But the only difference is that you're telling how much energy you're having in each shell. There's more calculations to actually get how much energy is producing, but this is just an idea of how much energy you will have. That's just really, really into quantized physics. So continuing on the same thing, if N is 3, what is E?
E3
E3 proportional
minus 1 over 9.
over 9. Yeah. So I'm going to draw this here. What will be E1?
Is minus 1 over 1.
Over 1. Right, that's the first shell. E2?
Minus 1 over 4.
Over 4. Right. E3, we just did right now. Do you guys see it? Do you guys see what's happening when I'm going out and out?
Yeah,
Yes.
What do you see?
it's getting less.
It's getting weaker.
Yeah.
That's what that means. That's how this part makes sense. The electron, if it's in this one, is stronger than the electron on this one. An electron on this one is stronger than the electron on the third shell. So that correlates with what again? In chapter 8?
Energy level.
Chapter 8.
Oh, that correlates to the IE,
IE, yeah.
ionization energy.
The ionization energy, yeah. So remember when I said about ionization energy? When it's on the last show, what does that mean? It's easier to what?
It's easier to remove.
Remove.
It's easier to remove, and you see why it's easy to remove. The E formula tells you. And when you move closer, it's harder to remove because the energy level is stronger than the one from the third shell. Questions?
No questions.
And Henderson, I'm going to explain to you Planck's constant. That is just a calculation on how to get E.
Okay.
Which is, hold on, where is it? It's triangle E H, equals H frequency. That's Planck's constants formula. No, Planck constants is DH. But using the Planck's
It has the constant number 6.6 something to the 10th.
So you use that calculation plus times the frequency, and you get the energy calculation, the change of energy that's happening from switching from one orbit to the other orbit. That's all what the Planck's constant is all about. He's not going to access this. He just throw it in there to help us understand how do we get E. Which is not chemistry, again, quantum physics.
It's not chemistry.
It's not chemistry, it's quantum physics. So that's why you guys are having a tough time. Because we're supposed to be learning chemistry, but we're learning physics.
So that's gonna be on the exam too?
Not this part.
Okay.
But it's good to know it.
Okay.
It's good to know it in case if he does, because you know how he is. He's gonna throw these curveballs out of nowhere. I'm trying to teach you as much as I can, all that I know so far with this. So that's the theory for the hydrogen atom and their shells. That's what's happening inside the shells. That's how you can tell the radius. So what's the radius again?
The quantize.
What's the quantized radius?
It's from the center of the atom to the end of the shell.
Right.
When the rings are touching, from the center of the atom to that ring.
Right. And the quantized energy level? What's the definition of quantized energy level?
The amount of energy, from the study got the amount of energy the shell is giving off.
Mm-hmm. So just remember those definitions and remember the functions. What was that? Sorry.
No, basically how you explain how the closer to the nucleus, the less negative, the harder to remove, the farther away, the tougher, the easier.
This
the
just
easier it is.
This explains IE much more clearly.
Number 4.
The energy unit, the formula for the energy.
Okay.
Put it back, baby.
All right, so just remember these 4 functions because that's going to be on the test. So when he asks you the functions of Bohr's theories for a hydrogen atom, these are the 4. Explain them. That's how they are right there explained. Don't write that it's the unit R or the unit E. Just be like spherical quantized orbital, the quantized radii, quantized energy, and the electrons give off light when they move from outer orbit to inner orbit. I wrote shell so we can understand it, but the definition is orbit.
Okay.
All right. Moving on, or any questions? Hayes, do you understand it?
Yes. So far.
Okay.
So
So
good.
far. Did you see the review sheet that I put?
Not yet.
All right, check it out. Use it right. You go along with it because that's gonna help.
Okay.
So right now,
Did you
I
send
posted
it?
on WhatsApp.
I see. Thank you. I'll check this now.
So right now, I'm gonna jump up to chapter 9 because I want to touch on the octet rule.
Oh yeah. Okay.
So, but first, before I continue on, I'm gonna give you some elements, and I want you guys help me solve it. So I want you to give me the structure, and I want you to give me the charge. Okay?
Okay.
And then I'll tell you the rules and tricks about how to fill this out and how you can do it next one. So for this one here, I'm gonna pick something easy. We're gonna do OF. OF 2. How would we write this?
is 6.
OF2.
Oxygen is 8. Fluorine.
You want to do it together? Because I want you guys to do this first and then we go over it.
Okay, I could do it over here.
You asked for the configuration?
No. You do in chapter 9, which is the dot structures.
Oh, okay.
Parents are here to collect the check. Where have I? Hello. Hello, everyone. Yes,
All right, we ready?
Yeah, let's go.
Henderson, we ready?
Yes.
Hayes, we ready?
Yeah.
All right. So how do we write this?
When it comes to play, my husband always finishes
Who wants to volunteer?
top answer.
Are we
Oh,
doing the low stack so?
Yeah, the lowest dot structure. Yeah.
Okay. Go ahead, Amani.
Here we go. We asked America. My kids spend all summer in the pool. Here at Animal.
Go ahead, hey.
you go first.
Oxygen in the middle
Okay.
and equivalent bond.
Oxygen in the middle. Okay. Then what?
And 50 seconds on the clock.
Is it F on the middle?
All right. So I'm getting two answers.
Oh,
So
no. Sorry. You're right. Oxygen in the middle and 2 F are in both sides.
F on both sides.
Yeah,
Okay.
and then equivalent bond.
We're gonna do the bond.
Yes.
All right. We're done.
Not yet. I think 3 over F.
3 over F.
Yeah, that's 3 bond. 3 like I mean 6 electron, right?
You want 6 electrons over F?
Yes. Not like that.
6 electrons over F.
Richard has got a medal. George has got a medal.
Hmm.
All right. So you guys skipped a step. Do you know how many pairs we have?
Nobody knows. You have to find out the pairs first. How many O's and F's we have.
Yes, we need to find the pairs first. You can't just randomly just draw the thing.
So O has 8 pairs.
What's the valence for O?
It's
It's
6.
8.
8.
The valence for O.
6.
8 or 6?
6. 6.
6.
Yes, baby, I'm busy. I work.
So oxygen has 6. What about F? How much the F has?
I think it's
7
4.
multiplied by 2.
Oh, it's 7? Okay, I thought it was 4.
7
7
times
multiplied
2,
by 2.
right?
14.
So what's the total?
20.
20 divided by 2.
20 divided by 2. Okay. And then how many we have? How many pairs do we have in total?
10.
10
10.
pairs. So we have 10 pairs. Now we just use 2. Now we have 8. Where did they
Yeah.
go?
Can we
So
do... I'm sorry. You go ahead.
Go for it, Hayes.
Can we put
What's the
wait,
second
let
rule?
me count.
What's the okay? We did the first rule with the valence. The second rule we made the bond. What's the third rule?
Can we add 2 lines in between S and O?
You want to put a double bond?
Yes.
You're skipping the third. You're skipping the next rule.
Oh, we have to put
And 3 lines
on
on the
each.
S, on both S.
Complete the octet. Yes.
Yeah.
Yeah. And
So we
then
just use 1, 2, 3, 4, 5, 6. Now
5,
we got
6,
2 left,
7.
2 on oxygen.
and the last 2 go on oxygen. And there you go.
Oh yeah. Okay. I forgot about the oxygen.
Just follow those steps.
Okay.
Step 1. Find pairs. Step 2.
Create the bond.
Create the molecule
Okay, the molecule.
or the bond, however you understand it, molecule or bond. Step 3. Complete octet. There's a step 4, but for this one, there's no step 4. But now let's find the formal charge of this whole molecule. How do we do that?
You have to let's say if
Number
you
of
want.
number valence of electrons.
That's the formula, right? So let me write it here. The formula.
Minus number of covalent bonds.
So it's number of valence
Of electrons.
minus, oh yeah,
Covalent
of the
bonds.
electrons. Okay, I wish my computer would stop being dumb. Minus
Covalent bonds. Number of covalent
of
bonds.
bonds then what's next?
Minus number of non-bonds.
Non-bond what? Pairs? Electrons.
Electrons.
Electrons, yeah. So that's the formula. I'm gonna put it over here. So let's work with this one here. This guy here. F. How many valence does it have?
7.
7. Minus how many bonds?
1.
1. How many non-bond electrons does it have?
6.
3.
6.
6. Electrons.
Yes, sir.
All right, and the total charge will be
0.
0.
Can I ask a question?
Go for it.
I totally forgot how did we got the 7, 1, and 6?
How many, what's the number of valence electrons for F? We're working with F right now.
Okay.
Case. What's the valence for F?
Oh, okay. 7.
You got it? All right, so I put the charge here, 0.
Oh, wait. Why 7? Why 7?
What's the valence?
Okay. Sorry. Yeah. No.
How many electrons are in the outer shell?
Me nothing.
Okay.
Yeah.
Okay.
For fluorine.
Chlorine is 7.
Yes, fluorine has 7 electrons on the outer
Yeah,
shell.
I know. I know. So I'm just
That's all right.
confusing
It's all
myself.
right. It's all right. That's why we're here.
Mhm.
So the charge for fluorine is 0. I wrote it up here. Now let's do the next one. This guy. Oxygen. What's the valence?
For oxygen,
Yeah,
6.
6. How many bonds?
2.
4.
2. 2 bonds. 1, 2. How many electrons?
4.
4.
4 electrons, right. And the total charge will be
0.
0. Now let's work on the last guy.
7.
Okay, New York yan, tita, di ba? Home alone.
7. How many bonds?
1.
1 bond. And how many electrons?
6.
6. And the total charge is
0.
0. So what does this mean?
Neutral.
It's neutral. This element here is neutral. All right. So that's one. We're gonna do a bunch of these because I have a bunch of them for you guys to practice. And then I'm gonna start throwing you some curveballs and see if you guys are ready for that. Okie dokie. I'm gonna give you an easier one. Give me H2. What's the first step?
Need to find the pairs.
So what's the pairs? How many pairs do we have?
1.
Just one pair. How do we write it?
H and both side.
H and what?
Another H on the other side.
Mm-hmm.
And the covalent band in the middle.
And that's it. And what's the charge would be?
Oh, 0.
1 charge. Sorry.
This will be 1 charge. Let's check it out. How many valences does it have? 1. How many bonds does it have? 1. How many does it have on the outside? 0.
0.
Charge 0. Repeats on the other side as well. 1, 1, 0. So H2 is 0. It is actually a real, by the way, a real molecule. I'm giving you guys real molecules. The other one was also real. OF2. I'm not making this. I'm not making up this formulas and everything. So these are actual real.
You're gonna make me mad.
All right, so let me step it up a notch now. Let me give you something tougher. Let's see if you guys can get this one. This one, you guys know what this one is?
It's a
Carbon dioxide.
Carbon dioxide, right? So I'm gonna let you work on that, and then we're gonna work on it together. So I'm gonna give you like a few minutes to work on that. It's a real molecule, you see. Mm.
More.
Give me a second, I'll be back.
Okay.
Take your time.
All right, we ready? Oh, you guys need more time.
I'm good to go.
Ready.
Ready? More time?
Yeah,
Anderson?
we could go. No, we could go.
All right, so let's work together. What's the first step?
You need to find out the pairs.
All right, so let's find out the pairs.
So carbon has 4. Sorry, it's a little low. Oxygen has 6 and parentheses 2. That'll be a total of 16.
Okay,
And 16 divided by 2. That leaves you with 8 pairs.
so we have
And then
8 pairs to play.
Yeah, now we're gonna move on to step 2. We're gonna create our molecules or bonds. So we're gonna put carbon in the middle, and then oxygen and both sides. And then 1 and 1.
All right,
This step we're gonna create a molecule. It's O connected to C, then the other O connected to the C. That will leave us down to 6 pairs. So now we got a little wiggle room to play with. So we're gonna go to the first O to that. Yep. We're gonna create 2, 1 on the side, 1 on top.
Bilang.
That'll be 4. So that's 2, 4, 6. And I'm gonna go to the other side.
Oh,
I'm gonna create a double bond on that O because closer to the right side. Then another line on the outside of that O. And then 1 on top. So counting that off, that'll be 2, 4, 6, 8,
Another
10,
double
12,
another
14, 16.
between carbon and oxygen.
Sorry for the wrong.
we have 7 pairs.
Yeah, another one right here.
Where?
Between on the first oxygen and Carbon?
Here?
Yeah.
Okay. So this is where step 4 comes into play. Because you guys skipped step 3 and went straight to step 4. Step 4 was
I did another.
is to adjust the octet.
I put three lines on the both sides of O.
All right, hold on. I want to draw yours too right now. Give me a second. Let me draw yours right now. I'm gonna draw it over here. You got O, C, and O. Okay.
Yes.
You said you did 3 lines here?
No, just one.
One
no,
line?
No. Yeah, just one.
Okay.
One line and another line in between O and C.
Here? Okay.
And then for the first O, I put 3 lines there. Then another line on the second O for three.
Right, I guess. Okay.
But I don't know if I did it right.
So you stopped here.
Yes.
You didn't continue on to step 4, which is to adjust the octet. Because right here, you see here, you have 1, 2, 3, 4 pairs, which means this is full. There's 8 electrons, so it's happy. This one has 1, 2, 3, 4, 2 of them each, 8 electrons. This one is happy. But this one here, this carbon, only has 1 and 2. 2 pairs, which means only 4. It's not happy. It's not full. So we have to adjust the octet.
Oh, okay.
So to adjust it, what they did was this. We can remove one of these lines from the outside. And make another bond. Same thing with the other one. But before I continue on, let me explain to you here. Let me explain this. Yeah, now this is still good because it still has 8. 2, 4, 6, 8. It's still happy. This is also has 8. It's also happy. But this one here only has 6. 2, 4, 6, 8. 1, 2, 3, 4, 5, 6. It's not happy yet. So to make it happy, we have to remove another pair. Move this one and bring it over here. Now they're all happy.
Okay, thank you. No.
See? 1, 2, 3, 4, 5, 6, 7,
Got
8.
it.
And there's 8 here as well. So that's step 4. So when you complete the octet, that's where you were, now you have to adjust the octet, which is step 4. So what's the total charge of here?
So we need to find that out. By finding that out, we need to find
One at a
the
time.
outside value for exactly for oxygen. Let's do oxygen first.
So oxygen. Well,
So oxygen is 6.
the valence is 6.
6 minus 2, 4.
2 bonds, right?
Oh, sorry, 2 bonds, yes. And then 2, 4. 4,
That's
sorry.
4 electrons, right? And the total charge would be?
0.
0. So mirror image. So we don't have to write this twice. It looks exactly the same on this side.
Okay.
So the charge will also be 0. Let's do, but we can check it if you want to check. It should be 0 because they look exactly the same. So we can check. What's the valence? 6. How many bonds? 2. And how many electrons? 4. So it's the same. That's how we checked it. Now let's do carbon. Valence?
4, 4
4
minus 4.
4 bonds.
4
And how many
nothing
electrons?
else, 0.
No electrons outside, right?
0.
And the charge is 0.
So 0.
So that means carbon dioxide has a what charge?
0.
0 charge. There you go. Isn't that interesting? The air that we shoot out is no charge.
Mhm.
A breath is carbon dioxide and we have 0 charge.
Mm.
Damn, that's crazy.
Can I ask a question?
Go for it.
Okay. So the goal here is we should complete all the octets. If one of it is not complete, so we have to adjust the octet.
Yep.
Okay.
Yeah, they all have to have an octet.
Okay. No.
So I have another one for you. Another known molecule, and it goes with your question, Hayes.
Okay.
You guys know this one? O3,
Trioxide.
ozone. It's an actual molecule, and there is an actual structure for this. So I'm gonna let you guys work on this for a bit, and then we're gonna go over it together. There's many ways to write this. All right, let me know when you guys are ready so we can do this one.
Yes, we can start.
All right, so what's the first step?
We need to find a number of pairs.
And how many pairs does O3 have?
That'll be 18. Then you have to divide by 3.
18 divided by 2.
That'll
It's
be 9.
So now we're dealing with 9 pairs.
What's the matter? We're in a secret club doing secret.
All right,
Told everyone. Oh, can I be in
let's
your
create the molecule. How will we write it?
Please, I've always wanted to be in a secret club. It's very hard to get
You have to O.
this. Pick a needle noodle. Pick a needle noodle. That's it. You're in. What happens now?
Now create the molecule. Plus minus 2. That'll be 7. So we could form a double bond on the right O. And then one here.
6 left.
three on the first O.
3 lines.
No. One on the top, below, on the other side.
We got 3 pairs left.
And one on the top of the second O.
Okay, 2 more.
One below.
And the last one.
One on the middle O.
Did everyone get this answer?
Are you able to readjust it?
To where?
That's the answer.
You didn't get this answer?
Yes.
I didn't.
First.
I expected this already.
What did you get, Hayes?
I didn't try it because I don't know how to do it. I only put 2 O's.
Oh my God.
I know.
All right, so let's work with this one together then. Why did you put 2 O's?
I don't know.
It says
I followed
3.
the.
It tells you right there.
Mhm.
3 O's. All right, so all right, Hayes, the first step we have to do is create the bond, right?
Mhm.
You know how many pairs you're working with?
9.
9 pairs. All right, so we make the bond to create the molecule. That means this is the bond, right?
Mhm.
So once we do that, we already use 2 pairs, so now we have 7. What's the next step?
Complete octet.
So complete the octet. How do we complete the octet?
So you put bond on the side.
That's complete.
Okay.
That's complete. And we do this. This is complete. So we have, let me see, 2, 3, 4, 5, 6, 7. Now we're done. We just ran out. We complete the octet. Now we did step 3. Now we're going. Let's move to step 4. Now we have to adjust the octet.
Adjust the octet. Okay.
Now we have to adjust it because you see this O here.
Yeah, it's not complete yet.
It's not complete.
Mhm.
So how do we get it complete? That means you have to remove a line.
Remove line. Remove one line in the O. In middle O.
This O? Oh, the middle O?
Yes.
All right, to where?
If it's possible. And move it to the right. Oh.
Here
Yeah.
or here?
Should it be there?
You guys don't complete the octet yet. You have to put it.
I know, I'm
only
seeing that. I'm seeing
7.
that. I'm seeing that right now. I'm like, wait, why am I missing some lines?
Mm,
I'm missing some lines. Hold on. 1, 2,
there's
3,
only
4, 5,
7.
6, 7, 8, 9. There we go.
Mhm. Okay.
We're missing some lines.
So we can we move the line in the can
You
we
doing right. We can move this middle line, right?
middle line on the and move it in between the two of
Here, right?
mm-hmm.
And there you go. Now they're complete. Let me show you. This is complete. There's 8 here. This is complete. There's 8 here.
Mm-hmm.
And this is complete. There's 8 here. So Henderson, you didn't get this answer. You got another answer, you said.
No, I was wrong.
Because there's an extra thing I want you guys to understand. You could also write it like this.
But that's my that's my question to you. I thought when it goes to the right in a double bond, it will be stronger.
Let me tell you something with this. This special molecule, it doesn't matter how you write it because this is called a resonance. So when you can write it more than one way, it's called a resonance.
How do you know if that molecule is a resonance?
When you can write it more than one way. The only way to know is when you write it.
Okay. Okay.
You can't tell by looking at it. You have to start doing it now.
Yeah. Makes
But I
sense.
think I'm spelling the word wrong. But it's resonance. Resonance. So you can write it more than one way. So it doesn't matter if you write it this way or this way. They're both the same. Because when you do the charges, they equal the same. Does that make sense, Henderson?
Yes, you said because it's a special molecule. Yeah.
All right. Any questions? No questions? All right, moving on. Now that we're done with the neutral charges, let's play with some ions. Give me this one. I'm gonna write two of them. I want you to give me the neutral and the cation.
Hello?
Yeah, Amir.
You want us to solve this?
Yeah, both of them.
I think.
All right, we all ready? Okay, Hayes. You ready? Hello? Hello?
We're here.
Yeah, I'm right here.
I was making sure my mic was working. You guys need more time?
We can do it.
Can do it?
Yeah.
All right. This was a trick question. This is my curveball I threw at you guys. So we're gonna do this part here last. But we're gonna do this one here first. So step one, find the pairs. What's the difference on this one than the other ones that we were working with?
What is it? We have to put that on the bracket.
Well, yes, the answer, it has to be in brackets, correct. But what else is different?
We're gonna remove one electron.
Right, because of the positive. So how much pairs do we have?
8. Eight electron. That means
Let's find the pairs. How much valence does nitrogen has?
it's 5. 5.
5 pairs, right. Hydrogen
4.
has 1 valence times 4. Times 4.
And -1.
And -1, right. And we get a total pairs of
8.
8.
8 electron.
And then what do we do? And then we divide it by 2.
Equal 4 pair.
4 pairs. So we're dealing with 4 pairs. What would go in the middle?
In.
Okay.
H at the top. At the bottom. And both sides.
Like that?
Create the bond. And we put the bracket. The bracket. and the side plus, right?
Right. That's how you write it, correct. So how do we confirm the charge?
Oh, it's
What's N?
N is 5 minus 4 minus 0 equal 1.
So N has a +1.
Yeah.
So if N is a +1, that would mean everything else must be what?
0.
Must be 0.
What?
So we can confirm. Let's check it.
Taste.
Valence,
1
No.
bond,
minus 1,
electrons,
0
0,
equals 0.
0. And there you go. That's how we confirm the formal charge.
This chicken's my favorite.
Now this one was a bit tricky, right?
Yes.
This does not exist.
Yeah, because it's gonna be 9 electrons, and we can only have 4 bonds. That's gonna be, we're gonna have 1 more electron left. So
No.
that doesn't exist.
It doesn't exist, but on paper, on theoretically how we could do it, it can when we write it down. But chemically, it does not exist.
Okay.
So let's do the same thing here. Step 1. What's the pairs?
5
5
plus 1 times 4
1 times 4
equal 9.
equal 9. And this part was difficult because when you divide by 2, you get a fraction or a decimal. So what I do here is pretty much, I just leave it the way it is. That means we have 9 electrons.
Okay.
We have 9 electrons, or in other words, we have 8 pairs.
So we have 4
I
pairs.
mean, 8 divided by 2, which is 4 pairs, and just plus 1 electron.
Yeah.
That's how it looks.
Mm-hmm.
To write it out, it'd be like that, almost the same way. But it's just something extra. And in the middle, H, 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 and H. Make the bond. And now we're left with 1 electron, and you could put it anywhere on the H. That's how this one looks.
So it's gonna like 1 edge gonna be overcharged. Gonna have like,
H is not overcharged.
yeah.
No, it's not overcharged.
The interesting journeys change all. You have a very healthy fish.
Okay.
More chicken?
I need something.
So if we do the formal charge, the math,
I didn't need chicken.
N is, the valence is 5. We have 4 bonds and 0 electrons on the loose. So that equals +1. The other H's would be the same thing. This would be a 0, this would be 0, this would be 0.
That's gonna be different.
The only thing is this one is what makes the whole element neutral. Let's do the math. What's the valence on the H?
1,
1. How many bonds?
1,
How many loose electrons?
1.
1. So the charge is -1.
Yep.
So nitrogen, which is +1, and this one is it's -1. They cancel each other out, plus and negative
Mm-hmm.
equals 0.
Okay.
See how it's not overcharged?
Yeah, I got it.
So I put that one on purpose. But at least you got the idea of how to do the things, how to check the charges and how to create the structure.
Okay.
All right, let me throw you another harder one. Henderson, did you get it?
Yes, I got it. The other NH4 is plus, so it's a positive charge of 1.
Mm-hmm.
My question is, you see how you wrote 9 electron E minus E? You think he's gonna ask to write that out like that?
I don't know. I don't think he taught us. This is the free radical question, because this when you have a loose electron, that considered a free radical. So I don't know. He did teach us this, but I don't know if he's going to ask that.
All right, no problem.
All right. So let me throw you a tougher one, since I see you guys getting the hang of it. This one is really, really going to throw you off. You guys ready? No one's ready? Hello?
Yeah, I'm here.
All right, so we ready to write this one?
Yes.
This is an actual element. This one exists. This molecule actually exists.
I'm not done yet.
Okay.
SO4 -2.
Mm-hmm.
You can do that. We don't want to win another giant teddy bear. Sad worry. You won't win. We need a useless. I'm sorry, what did you say? It's a game of skill. How much for one go? £1.
So I'm gonna give you guys a few minutes. This one's a little tough one. It may seem easy, but it's not. Because I want you to check the charges in the end. It's supposed to be -2. Let me know when you guys are ready.
I'm ready.
Henderson?
Never seen anything like it. That wins all the giant teddies we have.
Deal.
We could start do it alone.
I want to do this one with you, Henderson. Hello.
I'm here. We could do it alone. Let me just get a pen and paper. I'll just get inside the car. But you could do it alone.
No, I want to do this one with you.
Yeah, we can do it right now. We can
All
do it
right.
right now.
All right. So how many valence does S have?
It's 16 total.
Wait, Amani, let Henderson answer.
Oh, I didn't hear that. Sorry.
Excellent, Rebecca.
14.
S has 14.
16?
How much what's the valence for S?
For sulfur.
That's sulfur, right?
Yeah,
How many electrons on the outer shell?
14.
There's no 14 electrons on the outer shell. It's in the oxygen family.
Yeah, I'm look.
6. 6 electrons.
Okay.
And oxygen has
6.
also 6, right?
Yeah, but parentheses 4.
Times
And then
4.
plus 2. Plus 2.
Plus 2 more electrons, right? The total will be
That's 12. 12 times 2, 24 plus 2 is 26.
divided by 2.
Um,
It cannot be 26. 6 times 4, it's 24. 24 plus 6, it's 30. 30 plus 2, it's 32.
Ah, damn, and money's going hard on you, Anderson.
I know because I don't have no paper, no calculator. I'm just in front of the car. Give me 1 second. 32. Sorry. Divided by
32 divided by 2, what you get?
16. 16.
So we have 16 pairs.
So now you put S in the middle and O and O4 size.
S in the middle and O on all 4 sides. Okay, I'm gonna rewrite this much better. All right. Next what?
Now you're gonna connect O to all 4 sides of the S. So that minus 16 minus 4, that will equal to 12. So you have 12 pairs left. And then we're gonna start filling them in.
Complete the octet on all of them?
Yep.
So 1, 2,
2,
3,
3,
4,
4,
5,
5,
6,
6,
7, 8,
7,
9, 10,
9,
11, 12.
11, 12.
Are we
And then
done?
we're gonna, nope, we're gonna do the brackets.
Okay.
So plus, well, minus. We know we're gonna end up in minus charge, minus two
2.
charge.
Right.
So now we have to find this out.
Now we have to see if your structure is correct.
Exactly.
And let's see
By
if your
doing that,
structure.
let's start for O.
You gotta start with
So-
O. All right, so let's start with O.
So 6 minus 1, 6 minus 6. So that'll leave us with a
You got this.
minus charge of 1.
Right.
So if we know that we have a minus charge of 1, it's
It's
gonna be
this.
an O. Exactly. There's another minus charge somewhere.
So we have.
Well, no.
So
no,
right now we have a minus charge of
there's
4.
There's a minus charge of 4.
Right.
So we know there's a minus charge of 2 somewhere. I mean, a plus charge of 2 somewhere.
All right, so let's figure out the S.
Exactly. So it's 6, and then minus 1, 2, 3, 4. 0. So that'll give us a plus 2 charge. So negative 4 plus 2, it gives us a negative minus 2 charge. Yay, it works out.
Yes, technically yes. But apparently this is not the correct way.
No.
Mm-mm. How I saw it and how the guy explained it is that we had to take these 2 off and create a double bond. But regardless, it still equals the same. Because if we do the S, balance of 6 minus bond of
Oh, that means S is overcharged now.
no.
It's
That's
over.
like,
No, we did the wrong bond here. We did the wrong math.
Y-
It's supposed to be a 2.
no.
Let me show you. This is how we had it before.
Yeah.
But we had a 4. Where's the 4 when there's only 2?
Yeah, that's the phone. The
Yeah,
phone
that's what I said. 6 minus 4 equals
Equal
to a plus 2 charge. So negative 4 plus 2 equals to a negative 2.
Okay, so why did the guy explain? Because he said, okay, let me do the charge that he explained then. I'm gonna keep it like that. And let me go with how he explained it because he said this is supposed to be like that. So let me do S6 with a minus of 1, 2, 3, 4, 5, 6 and 0.
You see how many bond S has now?
Yeah, that's fine.
Not 5.
No, that's fine.
Oh, it's fine to have 6. It's supposed
Yes,
to be 4.
because again, this is the next part that I want to touch upon, which is the exception to the octet rule.
Oh, okay.
So now that we do that, these O's become different. So here we have a valence, okay, O. We have a valence of 6 minus 2 bonds minus 4. That equals charge of 0. And this also equals charge of 0. And there you go, your -2. Why if this one works and the other one doesn't is because according to the exception of the octet, S needs to be neutral. S
Why?
cannot be a positive. That's the rule for the exceptions for the octet.
Okay.
So the ones that needs to be neutral is carbon, nitrogen, oxygen, fluorine, sodium, and magnesium. Sometimes hydrogen. But when it comes to this, S needs to be neutral.
So for this is the assumption of the rule.
For this is the exception of the rule, right? So when it comes to the octet rule and how you guys got confused, like, wait, how can you create more bonds? Any element on the line, on the third line going down can create more than 4 bonds.
Any element on the third line
Going down. Can have more than 4 bonds. Total 8.
are you talking about in the periodic table?
Correct. So here's the rules that we have here. On the second periodic table of elements, the second line, those elements cannot have an expanded octet. Cannot. So anything from the second line going up cannot have expanded octet. Elements from the third line going down can have expanded octet. So the octet can be expanded beyond 8 electrons, but only for the atoms in the third in the periodic table or below. So here are the rules that I wrote down on the sheet. No Lewis structure is complete without the formal charges. The fewest number of formal charges possible, for example, a formal charge of 0 for as many of the atoms in the structure as possible. The formal charges should match the electronegativity of the atom. That is, negative charges should be on the more electronegative atoms and positive charges on the least electronegative atoms, if possible. So that's why when you see on his review sheet, look at the S. On the professor's review sheet, he has one element that has like 6 bonds to it, and that's the SF6. There you go. The S is on the 3rd line. Look at number 4, where he has PCl5. Look what line the P is on. So those are the rules you got to remember. This is not considered a resonance.
So this won't be considered a residence?
It's not. Because the other one, the sulfur was a -2 charge. Was a +2 charge, I think, right? As we got the answer, yeah, it was a +2 charge. And the rule states the formal charges should match the electronegativity of the atom. So that means SO is a neutral charge. So it's supposed to match as a neutral. I'm gonna give you another one, so you guys get more practice with it. All right? Any questions?
No questions, David.
All right, so I'm gonna do the next one. And it's the same thing that we're doing right now. Use your periodic table and look at which kind of element you're working with. All right, this one is going to be PO or -3. Missing a root.
What is the valence of P?
What is the valence on P? Which family is it on?
Mm,
Look what's on top of the P.
I don't know. I don't have the table with me.
Nitrogen.
Okay.
How many valences does nitrogen have?
There's 5.
5. So if it's in the nitrogen family, so that means that one has the same valence.
Okay.
You guys should come prepared with the periodic table. I'm gonna put another rule here so you guys can see it. There's a rule I put there. When you're going down on the periodic table, or when you go to the left, the element is less electronegative. Another rule I'm going to put up here as well. The less electronegative always goes in the middle.
What do you mean by going down or to the left? Like you starting from the right,
Mm-hmm.
like by helium?
Mm-hmm. Helium is the
Okay.
most electronegative. Hydrogen is less electronegative.
Because of the noble gas core.
That too. It has more electrons. Remember the energy level I was talking about?
Yeah.
In the beginning? When you're
Yes.
going down in the periodic table, you're going outer shell, outer shell, outer shell. Less electric negative. Going across, you're going to the left. You're losing electrons, less less electronegativity. You go to the right, you get more negative. You're getting more electrons on the valence. You go up in the periodic table, you're getting closer to the core. You're becoming more negative, more stronger. The closer you are, the stronger the negative. The farther you are, the less negative. You guys need the periodic table in front of you.
I have it in front.
Hey, did you bring me dinner?
Sorry, I finished it.
You're so mean.
I know. You want tinapay? You
Do I
guys
want to
want
bite?
tinapay?
What is that?
Tinapay is the bread.
You said tilapia?
No, that's the first.
I'll,
Tinapay is the
if
bread.
it has no pork, I'll take it.
You don't eat pork?
I don't eat pork. No.
Why?
I don't like the taste.
Really?
Tastes disgusting to me. Sorry.
No way. Pork is
Way.
so good.
You don't know what you lose.
Hmm?
All right. So you guys ready to go over this?
I'm gonna listen to it first because
Yeah, because you missed this part here. So
yeah,
this
I
part,
missed this
this part
part.
you need to understand
Mhm.
it. Right now, this is what
Mhm.
we're doing right now. This is the topic.
Mhm.
Um,
Is this still part of your Lewis structure?
exception to the octet rule.
Okay.
That's what we're doing right now. The exception to octet rule.
Is this where you put the bracket?
No, that means we can put more bonds
Okay,
on
I'll listen to you guys.
on more on certain elements, not all elements, on certain elements.
Mm.
All right. So let's start with P. How many valence does P have? What's the valence for P?
5,
5. Oxygen?
6,
6
parenthesis
times
4, plus 3, A, A plus 6, 23. Hold on, let me do this one second.
32.
Damn, Henderson.
Is it 32
It's 32.
divided by 2?
All right.
I'm in the car.
Oh, shoot. That's why. All right, no problem. You got a free pass.
Yes, yes, yes. Like an easy pass.
32 divided by 2. What is it, Hayes?
16?
16. So we have 16 pairs.
One second, I have a question.
Yep.
So it doesn't matter if it's -3 or +3. When you find the pairs for it, you have to add +3.
Oh, no, it does matter. It's just that right now we having -3.
Okay, okay, okay. Thank you. That's it.
Okay.
Mhm.
Ooh, I'm gonna put another rule here. I'm gonna put another rule. All right, so let's start building it up. Let's start drawing this guy. So according to these rules here that we have, what is going to go in the middle? The O or the P?
The P.
The P. Why? Why the P?
Because
Where's your table, Helmani?
I don't have it with me.
Go get it.
I left it in my car.
We'll find one online.
Okay.
Hayes, you have the periodic table on you?
Yes, I have it on me.
Okay. Henderson, you got a free pass, so.
No,
You
I have the table. I have the table.
All right, so why should we put the P in the middle?
Because you have 4 O's that are connected to it. That shows in the bottom, O4.
Because it's less electronegative.
Yes.
Okay.
It's less electronegative on the periodic table. Remember what I said?
Mm-hmm.
When you
Yes.
go down, you're less electronegative. You go to the left, you're less electronegative. Look at the O and look at the P.
Mm-hmm.
O and then P.
O is on the second line, P is on the third line. So P is more negative because it's going to the left and it's going down. Not because of the bond, not only because of the bond that you're creating, you have to know this rule.
As long as experiments need to help and then experiments need to work.
All right, and then we do the O's. They all go around. We have 16 pairs, so let's create the molecule. Twelve pairs left. And then technically we're supposed to put them all like this.
But it's not gonna be like that.
It's not gonna be like that, correct?
This is try again. Wait, let me show you. Look.
How will we write it?
This.
What are we moving?
One pair from each side.
Each side?
Oh, I mean left and right.
You just need one pair from one side.
One pair.
Yep,
Okay.
just one pair on one side. Doesn't matter which side. This what makes it resonance.
Okay.
And that's, are we finished?
No. We
Why
need
not?
another.
What do we do after this?
It's 16. 3. That's 4. 8. 12. Okay.
What else do we do?
Daddy, press this. No. No. Yes. Now you can play. No. You didn't. Just play a little bit.
Mr. Uber driver, what do we do after this?
You gotta put brackets.
Brackets.
Bracket.
Don't forget the brackets because it's a -3. So putting this line here, Almani, what does that do?
Like, wait a second. Neutral, you gonna make the oxygen neutral, right?
It makes the oxygen neutral.
Yes.
Let's do the calculation. Valence of 6. How many bonds?
2.
How many electrons? 4.
Oh.
So it makes O neutral. What about the P?
It's gonna be
Valence
neutral
of
too.
5.
Minus
5
5.
bonds. 0.
Minus 0, neutral.
Yep. Because it's following the rule. So that means the negative charge should be on more on electronegative atoms. And the positive charges on the least electronegative atoms, if possible. So it's possible here. This is the least electronegative. These are the most electronegative.
Okay.
Charge is 0. And these equal 1, this equal 1, and this equal 1, and that's how we get the -3 charge.
So that's supposed to be oh yeah, -1, yeah. Okay.
So you see the P is on the third line. It's an exception to the octet rule because you have more bonds.
Mm-hmm.
And because putting this here, we have to make this here neutral, which automatically makes this one neutral. These need to stay more electric. Needs more electronegativity than this one. Any questions?
No.
All right, Henderson.
If you guys don't mind, can we do another example? If that's okay.
So I'm looking for more problems for you guys. Give me a second.
That's okay.
Because you guys need to practice on this part here. Because he might throw you something like this.
Yes, I think so. He likes giving us complicated problems.
Yes, he does.
He doesn't give easy problems.
Hold on.
Take your time.
Hey guys,
Hey, so Johnny.
Hi.
how's it going?
What's up?
We're
Nothing,
playing with
long day.
We're playing with structures.
I see.
We're playing with complicated structures now. All right, so I have another one. Another toughy one. This is doing we're doing exception to octet rule. This one here, give me a sec. It's gonna be SI F6 -2. Have fun. This one is not that tough. This one is simple. You guys see this, right? This one is easier.
I think I'm done.
All right, so let's start.
So you find the pairs first.
Pairs first, right? So SI, how many? What's the valence
SI
first?
SI is 4. F is 7 times 6. Plus 2 equals 46.
In
I
total
got
is 46.
46 divided by 2 is 27. Oh no, no, 48.
48.
Yep,
40.
it's 48.
48.
48 divided by 2, you get
24.
24.
24 pairs. All right. So according to the rule we have here, what goes in the middle?
SI goes in the middle.
SI goes in the middle.
Then 6F on the side. Up and on the side down. Si Paolo Conti.
All right, then what?
And then I put bonds in between
Next
SI
step,
and F.
create the molecule. So we just used up 6. So how many we have left?
18.
18. Now what? Where did they all go? What's the next step?
Put 2 bonds in each F.
Complete the octet.
Completely.
1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. What is wrong? Are we done?
No.
What's missing?
SI isn't complete, so we have to adjust the octet.
What was that?
This SI is not complete yet, so we have to adjust the octet. Oh, we don't have to?
SI is done.
Oh, okay.
So we just need the brackets.
Okay.
So let's check the charge to see if SI is neutral. What's the valence for SI?
4.
4. How many bonds?
6.
6.
Mommy,
Yes, baby.
tastes like it. Put it for me now.
And how many loose electrons?
0.
None.
0.
0. So then this charge is what?
-2.
-2. Give me a second. I had the thing. I just lost it. Okay. So according to this is the correct answer, but even though we have a charge of -2, which doesn't explain why. But I guess it makes sense more because the F are all neutral around it. F has a valence of 7, 1 bond, 6 electrons, 0.
Kala mo, ikaw lang marunong mag-
So I guess because of this, it wasn't possible to make this one neutral, because that's the rule right here. Formal charges should match the electronegativity of the atom. That is, negative charges should be on the more electronegative atoms, which they are. And positive charges on the least negative electroatoms, which it is. If possible. But because I guess all the fluorines are neutral, it gave the exception for the Si to be -2. I don't think this is a real molecule, but this is what I found online to practice this one with. Because the ones I gave you guys were real molecules.
Well, at least we understand the concept.
I have a question. Is it possible if he gives us like odd numbers?
I have one with an odd number if you want to try it.
Can we?
This is a neutral one.
Oh my God.
There's 3 in there.
Yeah. Mhm.
So follow the rule, less electronegative goes in the middle.
Yung mhm.
So when we do the additions, we have to divide now by 3 for the pairing.
I think
There's gonna be 3 elements.
Right, so we're
No,
dividing by.
divided by 2.
Oh, I thought
So-
we divide by the number of elements.
No, it's just divided by 2. Sorry.
It's always divided by 2.
Always divided by 2.
Okay. See, I would have done that wrong on the test. All right, I'm not sure if I got it, but I'll try.
Anyone else need more time?
Look at that.
I did it, but I'm not sure. I'm sorry.
Okay. Hold on, let me pull it up. All right. What's the valence for P?
5.
5,
Plus
Oxygen,
6,
chlorine,
6. Plus 7.
7 times 3,
equals
32.
so 21,
32.
it all equals 32.
divided by 2,
16.
16.
16 pairs. All right. According to the rules that we have here on the side, what goes in the middle?
P,
Why would P go in the middle?
It's less
less
electronegativity.
electronegative.
Mm-hmm. So P. We have 3 CLs and 1 O. How would we put them?
I have O on top of P and then CL around.
All right. What's the next step we got to do?
Create the molecule, so bond each.
Got rid of
Right.
4, so now we have 12. What's the next step?
Form the octets.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Yep.
And then what?
It's complete.
All right, let's check the charges. Let's do O. Valence. 6
6
minus
1,
1 bond minus
3,
3.
Six.
Oh, I keep forgetting
6
that
electrons.
it each counts for 2.
So this
Okay.
charge would be
-1.
-1. Cl is
7 minus 3.
where do you see 3 from? How many bonds do they have?
1.
Oh, you have to do each one separately?
Yes.
Oh, okay. I didn't do that.
Six.
All right. So see, 7 minus 1 minus
6.
2, 4, 6 minus 6.
And the charge will be
0.
0.
0. And P, valence of
5.
5,
5 minus how many bonds?
4.
4,
4. How many electrons? Loose.
0.
0.
Total charge of
1.
-1.
plus 1.
Yeah. Mm.
So we have 0 here, we got plus 1 here, we got 0 here, and we got 0 here. Is this correct?
I think so.
It is not.
Oh.
P. It's not going according to this rule. If everyone else was 0, P will be fine, but it's not. We're dealing with this guy here. He became a negative. So you have to adjust the electrons, the lines.
Mm.
How do we get P to be neutral?
So P needs to be 0.
Mm-hmm.
Move 1 bond to
Make a double bond.
Mm-hmm. Where are we taking it from?
Excuse me.
Bless you.
O.
From the O. And creating a double bond. Now let's do the charge calculation again. O has a valence of 6, minus 2 bonds, minus 4 electrons, charge 0. Now it's neutral. P, 5, 5 bonds, 0, 0, neutral. So prepare yourself, because he might throw you questions like this.
So on this one, we need to take from O because CL was already O or 0.
Yeah, CO was already
And we
neutral.
had to, got it. Okay.
That's like going, that's also we're not adjusting the attack anymore. Now we're adjusting charges.
Charges, yeah. Okay. That makes sense.
I'm trying to find a good one that gives like,
And with the one that goes in brackets, again, if it's a negative, we're adding 2 electrons. If it's a positive, we're subtracting, right?
right.
Okay.
I'm looking for another one so you guys can practice again, and then I'm gonna jump to something else. All right, I had you. I just lost the sheet and I just had it here. Okay, we can do this one. All right, let's do this one. Okay, you guys ready for this one? ICL for negative.
If it's just negative without a number, it's just a 1.
It's a -1, yeah.
Okay. Can each CL be like have a different charge? Yeah, right.
The rule says match the
They should
electronegativity of the
match.
atom that is negative charges should be on the more electronegative atoms and positive charges on the least electronegative atoms, if possible. So who's more electronegative?
Iron. Hold on, let me look at the chart. Chlorine,
Chlorine is more electronegative.
right?
Yep. I mean, it should have more it should have more the charge the it should the negative charges should be on the more electronegative. So it should have more electrons. All right, you want me to go over this? Or you guys need more time?
Good.
I'm almost done. All right, I'm done.
All right. All right, so Johnny, let's do this. What's the first step we do?
I has 7 valence. CL has 7 times 4, so that's 28 plus 1 because it's a negative.
Total of?
So total is 36. Divided by 2, we have 18 pairs. I would go in the middle.
Why would you go in the middle?
Huh?
Why would you go in the middle?
Oh.
I goes in the middle.
You need 4 CLs. 1 on top, 1 on bottom, 1 on each side.
Can we write it like this?
No. You have to be Picasso and put, yep. And then bond them.
All right, we bond them. So
And
that's -4, so we have 14 left.
And then form the octets.
Complete the octets. All right. So we used up 12. So that means you have 2 left.
So I put a double between the CL and the I on the left and on the right.
You want them to do the double? Okay. And then what?
And then check for the charge. So
We're not done here. You're missing something.
oh, your brackets.
Negative. Now let's check the charges. So what do you want to check first?
I checked iron first.
All right.
So I got 7 minus 6 minus 2.
There's no loose electrons.
Okay, sorry. 7 minus 6. Okay, I did that wrong. 7 minus 6 minus 0.
All right. So the total charge will be
1.
+1. All right. Let's look at
then-
this guy, this CL.
Okay.
What's the charge?
I got -1, so
What's the valence?
the valence is 7.
Bonds?
2.
Electrons?
6.
All right. So that would mean the total charge will be you said you got
Negative
negative
one.
1.
Yeah.
All right, so this is negative 1. This is negative 1. This is plus 1. And then this one. The other CO.
You're doing the bottom?
The bottom or the top doesn't matter.
The bottom, I got 0.
7 minus 1 minus 6. You get 0. Right. Does this go with the rule?
I was saying yes because it's still a negative. CL is still more electronegative. I don't know that that's right.
We cannot create a double bond with chlorine. Chlorine's already full with the octet. So what happens here? What happens here is that we end up having 2 extra pairs, and they just hang around the iron.
Oh, you can have it just going around 1?
Yes. Because the iron is less, it's less than the third periodic table. So iodine is the least electronegative. So
I keep saying iron, it's iodine.
is it iodine or is it iron? I don't remember.
No, I think it's iodine. Iron is
Fe.
yeah.
So iodine is in period 5 on a periodic table, so it can hold more than the 8 valence electrons. So that's why the remaining
Say that
2
again?
pairs, since iodine is in the 5th level, on the 5th line on the periodic table, it can hold more than 8 valence electrons.
Gotcha.
So another rule, I guess we're gonna start adding here, and I don't have space here, but a rule is when you're bonding, the least electronegativity goes in the middle and holds more valence. You can expand the octet. But even though chlorine is also less than the third periodic table, it's connecting to iodine. It's not the center. So that's why it has to complete the octet.
Okay.
Iodine is more electronegative than chlorine. So going back to the charges, since it looks the same as the other two, this equals 0, this equals 0. And then we do iodine. So we do 7 minus, how many bonds do we have?
4.
4.
4 bonds. And we have 1, 2, 3, 4 electrons loose. And the total charge would be negative
-1.
1. Yep. I'm looking for a plus one. All they keep showing me is negative. That's all I'm getting is negative. I'm not getting no plus. So from the pattern I'm seeing, from the last few elements, last few molecules that we did, everything, the charges around the the least electronegative has to be neutral. And the least negative and the least electronegative has to have a charge. It's in there. It's in there, but I'm gonna have to do some adjustments. Henderson. But at least you guys know the structure. At least you guys know how to do the charges.
Yeah, I
And just
definitely feel more comfortable with this.
and just understand that anything from the third line going down can have more than one octet. Can expand the octet.
Say that again?
Anything from the third line going down can expand the octet.
What do you mean the third line going down?
On
the periodic table?
Yeah.
Oh, okay. And the last row is, what do we call it? They're all,
Full.
oh my God.
All right. Any questions? Anything you guys want me to cover on?
What did you cover before I signed on besides this?
The beginning of chapter 7.
Okay. So
chapter
the
7,
wavelength and frequency?
right? And I
Okay.
continue on to the Bohr's atomic theory
Okay.
on the radius and the and the energy.
Oh, okay. All right, perfect. So when you post the video, I'll go back and watch that.
Okay. Any other questions?
Nope. You go get some rest.
Amani, do you get it?
Yeah, I got it. Thank you.
It's a bit confusing with the charges, but that's how it works.
I know. I don't think he's gonna give us something like that.
I hope not.
I hope not.
I hope not.
I hope not. Can we not do one double bond and add
Oh yeah,
another
you need to
bond?
practice more, Hayes. So yeah, let me do one with you. You need to practice
No,
more.
no. I mean, on that problem. Wait, on that problem.
Something. Tori, have you seen
David.
I have an easy one for you. You got this. You can do this one.
No, on that problem, I mean the ICL4.
Mm-hmm.
Are you trying to get a positive charge?
No, that one was a negative.
Okay.
Come on, Hayes, give me this one. You missed out, so you got this one.
1 multiplied by 3 plus 6 plus 1.
Plus 1?
Oh, no.
You subtract because it's a positive charge.
Oh, okay. Yeah.
I was confusing that myself, Hazel. That's
Yeah.
why I asked them earlier. When it's positive, you subtract.
Okay. Minus 1.
Mm-hmm.
So equals to 8 divided by 2. Divided by 2 is equals to 4.
4. All right, continuing the rules. Which is less electronegative?
Less is O
Oh, so that goes in the middle.
in the middle.
Right.
And then you put 3H on the side.
3H on the side. Okay.
Wait, I'm
Like-
gonna write it down.
Like that?
No, not that. 3H in between O.
3H in between O?
Another H on the left of the O,
Okay.
and on the top.
All right. So we have 4 pairs. What's the next step?
You put 3 bonds in between.
What?
In between O and H.
What's the next step?
Create a molecule.
Yeah.
And
So
then
create,
you put
so
three
create the
lines.
molecule. All right, so we have 1 left. Where does that go?
Put down on the letter O.
Here?
Yeah.
All right. And then what?
Bracket.
Brackets. All right. And after that?
Write it down.
Don't forget the plus sign.
Oh yeah, the plus sign.
All right. Now let's do the charges.
We'll see.
Let's do H. H has a
1
valence of 1.
minus 3.
3. There's only 1 H. How many bonds?
Oh, 1.
1. And electrons?
2. I
I
mean
don't
0.
0.
Yeah, 0.
All right. And the charge would be
0.
0. So that means it's neutral. 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 All right, so let's do O.
O is 6.
6. How many bonds?
3.
How many electrons?
Oh, 2.
2. And the total charge is?
1.
1.
I hope he gives us this one.
And that's why this makes sense, because everything else is neutral, and this one is a +1.
Henderson, don't laugh.
Did I do this right?
That is correct, yes.
Wow.
And this actually is true, H3O.
Okay.
I forgot what it is, but it's poison. It's more poisonous than water. It's more acidic, I think it is.
I hope he gives us something like this. This one
Yeah,
was.
I hope so. Do you think he'll change?
No, he's not
After
gonna change. He's gonna be a dick like he always is. He's gonna give us something hard. P orbital. What's in it? What are the L's?
-1.
L.
L.
Oh, L.
Is in 1.
L
1,
equals 1.
-1,
And?
-1. 0.
And 0. D's. What's the D?
Is that L2?
D is L2, but what's in it as well? Oh wait, no, yeah, D is L2. I meant to say N3. I meant to say N3. Give me the L's in N3. So the L2 is 1. What are the others?
L1.
L1 and
0.
0. Yeah. Okay. And the N4, give me the MS.
I think it's -1/2.
And
+1/2.
yep. You get both.
You got this.
I'm still struggling on the.
Oh, you
what
still
we did
struggling on this
yesterday.
one?
On the when you do the quantum at the end, I have
Is
to go back and practice with the chart you made.
The quantum numbers?
Yeah, you don't have to go over it again today. I'm gonna go back and watch it's just the when you write out the quantum number, how you did it yesterday, where you did each spin negative, like so you
with
can
each
see where.
element? He's gonna ask you that on
Yeah,
the test.
I know I have to go back and practice that.
MG. Configuration.
1s. 2.
1s2,
2s2,
2s2,
2p2,
no,
No,
You said
MG
One,
is
you said
in
magnesium,
2p1.
right?
mm-hmm,
2p 2p1, 2p
no,
2p2,
does it have P?
no,
p
it has P,
2p2.
no,
Oh, 2p6.
2p6,
Yes. If you wanted, yes. Then 3s,
3s, 3s what?
3s2.
There you go.
Yeah.
Mm,
Anything past 2p5
you
combined.
can combine.
What's the core for this one?
So because ends NE, sorry.
And E is the core. And what is the quantum number? And what?
L and L and N3.
And 3, what's the L?
The L will be isn't L2.
Look at it again.
Oh, 0, 0.
0.
And there's an S will land in 0, so that's 0. And that'll
Mhm.
be plus 1/2.
No, it's not.
Oh no, because it completed, so it'll be plus negative 1/2
Exactly.
because the core is completed.
There you go. You guys didn't see this one coming, huh?
Mm-mm.
I had to dig deep in my brain.
You got this, Henderson. You got this. So
My
just a
brain
good
feels fried.
it's a good refresher for this. All right, so everyone has a periodic table on them?
No, I need to reprint one. I've been going back and forth. I have a picture on my phone.
Because I need everyone to look at the periodic table for right now.
Okay.
Let me know when everyone's ready. Hayes, you got your table? Almani, you got your table?
Yes.
All right. Hayes, you got your table? Hayes? Henderson?
Yes.
You got your table?
Yes.
All right, so I'm just gonna wait for Soljani.
I got it.
All right, because I think Hayes stepped out.
I'm here.
Ah, I asked you for your table.
It's with me.
Okay, cool. So my rapper, this guy, T.I., also Liniment, is on which block on the table?
D?
Which one?
D?
No.
P.
Which one?
T-I?
Yeah.
Oh yeah,
It's on D, no?
it's
No,
on
it's
D.
no, it's not.
Oh,
It's on
but it was
D.
D.
Not D. Should we do the configuration so you can see?
It's on. It's in P block.
P block. Yes, it is. The P
I
block
thought
starts
that's
on B.
CL.
The P block starts at P and it goes all on the B on boron. That's where P block starts. On boron, B, and it goes all the
Oh,
way down to Ti.
that's CL, right?
Ti.
The one that you meant that is on the P is
Oh,
CL.
I thought that was Ti. I'm so
TI is in
sorry.
group D.
I am so sorry. I thought
It's
that was
okay.
Ti.
It's okay.
So yeah, TL. Okay, so yeah, you were right, so Johnny. Ti is on D and TL is on P. So
Oh,
yeah.
okay.
I thought that was Al over there.
Oh, you're going by the PB, next to the PB.
Yeah, I thought that was a TI.
Gotcha,
It was a
okay.
TL. All right, so yeah, so
Okay.
you're all right, cool. So what
I'm like,
about
okay, this, I have it as D block, but
all right? K is on which block?
That was a trick question.
for himself.
Ah,
K is on S block.
S block. And TC would be
D block.
D block.
D block.
All right. And what is the order for the configuration?
For what?
Or which one?
The off-ball order
For which? Oh,
in
just the
general.
alpha order in general.
Yeah.
1S, 2, 2S2, 2P2, 3S, 3P, 4S, 4P.
No.
I mean 3D, 4P.
3D,
Yeah, 3D, then 4P.
then 4P.
This is
And
for
then
which one you just did?
off-ball order.
Oh, you're not doing a particular element. That's why I'm like, wait,
Mhm.
what?
Just the order. Okay. And so Johnny, you missed out on this, so you don't have to answer this one. If N is 3, what's E?
3. So 3 to the 9.
Right. And R would be?
R will be 3. Then 3 to the second. Equal to 9.
Right. So you got it.
Yes, sir.
And formula for C?
So according to the textbook, and I'm going from the top of my head, is 3 times to the 10 to the 8, but he wants it as 3 times 10 to the 10 in centimeters.
I was gonna ask that because I saw that on the review sheet that you wrote the
Yes.
book and then our professor.
Mhm.
Yeah.
So why is there a difference? The book is
Because
doing it in
because
meters
we're exactly because in the
and
book
he's
it's on
doing centimeters.
yes.
This guy. So the answer though, didn't you say something was in nanometers? Not this.
I wrote it on the
So
review. The
yeah,
I know,
when you
I
get
just don't have it.
when you get problems, they will throw you in nanometers.
yeah, nanometers.
So how do you convert?
So nanometers is 1 times 10 to the negative
It to the negative?
To the
negative
negative
9,
what?
negative 9.
Yeah, yep, to the -9.
And you have to write the unit, so it's nanometers. So you
Alright.
plug that in to div, and then you use the formula.
Okay, so now what is this? Give me the name.
That's the quantum angular momentum quantum number.
And what's the definition?
So that gives the orbital its shape and the name of the orbitals.
Right. I mean, learn it as the name of the orbital, but the textbook, as you might ask for it, is the shape.
Okay.
It's the shape. And this one,
The principal quantum number.
definition.
Gives the shell level.
Yes, but now it's something
Energy,
else now
energy
because
level.
now it's called the energy level because of what we just did with the R's and the E.
Oh, okay.
Watch the video, you'll see.
I'll watch it tomorrow morning.
No, that's not what I wanted to write.
Last minute, he's switching up stuff.
Yeah, I saw that. I was like, what? But which furthermore is like such inconsistency, right? So if you've had us for the last week reading the textbook and learning it one way, you just want to switch it and then have us like just I can't undo what I just learned. Just don't understand why he can't be consistent.
That's the definition for the principal quantum number. And what's this?
That is the magnetic angular.
It's 4 quantum numbers, right?
Yeah, there's 4 quantum numbers, but what's the name of that?
So that's the
No.
the magnetic.
My question is like, it's you put N is one of 3 quantum numbers. I think it's one of 4 quantum numbers, right?
To categorize the orbit.
Oh, okay.
To
Got it.
categorize the orbit.
Okay.
Because I'm about to get there right now. MS only does what?
Only the spin.
It's only the spin. Yeah. It doesn't categorize it. It just tells you the spin.
Okay, got it.
ML is the magnetic angular momentum quantum number.
And all these are called what together?
It's called shit.
What are these?
Quantum numbers.
Yeah. And why do we use the quantum numbers?
To see the quantized energy.
You use quantum numbers to describe the distribution of electrons in hydrogen and other atoms. That's the definition. You guys got to know these two. The definition.
What is it called?
These are quantum numbers. Why are they called quantum numbers? What do they do? They describe the distribution of electrons in hydrogen and other atoms.
Okay. Thank you.
Got it.
I think that's all the definitions we need for him when it comes to the quantum, because I don't think anything else we need. I put extra definitions in the sheet so you can understand everything else. Oh, I see which one. This guy. Mr. Hans. He has two rules. What's the first one? I'll give you a hint. It has to do with the spin.
The most stable arrangement, right?
I know one is the max spin.
There
and
you
the
go.
second one is the orbital symmetry.
Allowed max spin. And the second rule is orbital symmetry. And now for our other friend, Paul A. What's his rule?
About letting the fill up in the subatomical level.
Isn't that one no, like they have to
no true electron?
Right.
Can have the same, yeah.
No two electron. Keep going.
And the same atom can have the same set of 4 quantum numbers.
Correct. No two electron in the same atom can have the same set of 4 quantum numbers? So this is the last one I'm going to ask. Last question I'm going to ask, and then we're done. Give me, for the F orbital, F type, give me all the quantum numbers.
It's 5. I'm wrong.
Thought
Yep,
it
you're
was
wrong.
7. 7.
Oh, it's 6.
Give me all of the quantum numbers.
3.
The whole list. The
Three.
list there is 14.
3.
No.
Oh, n equal like 6 or 5.
F is on which shell?
5th.
Yeah, 5.
F is on which shell?
I think it's 5.
It's the 4th shell.
So it's on the 4th shell, so then it's going to be what?
4.
4.
Oh, okay.
What's the L?
3.
3.
3. ML.
3 minus 3. Minus 3.
We can take any of them, right? -3 or -2.
Yeah, but we're going to go in order, so -3.
Okay.
-2.
Okay.
-1.
Plus
1/2.
1/2. All right, that's 1 out of the 14.
Then continue on, guys.
What's the next one?
4.
4.
3.
3. -2. 1/2. Plus 1/2.
Mm-hmm.
4. 3. -1. Plus 1/2. 4.
4.
3.
3.
0.
0.
Plus 1/2.
Hayes, why are you not answering?
She signed off.
Oh, she did? Oh, shoot, I did not see that. Oh, okay. All right.
4. 3. Plus 3.
Plus 1.
Plus 3, okay.
Minus 1/2.
Okay.
4. 3. 2. Minus 1/2.
4. 3. 1. -1/2.
All right, you guys are halfway there.
4. 3. We did
0. Oh, we did 0 already, right?
3,
Yeah.
2. Yeah,
Remember,
you
you
did
are
0.
halfway there.
All right, so we have to go back and do -3 and -1/2,
Mm-hmm.
and then 4 3, -2, -1/2.
All right.
4, 3, -1, and -1/2. And 4, 3, 0, -1/2. 3, hold on, 0.
If you want the fish to bite, you first
Three.
have to feed the
3, +1/2.
Mm-hmm. 2 more.
4, 3, 2,
1/2.
+1/2.
And the last one.
4, 3, 2, sorry, 4, 3, 1, +1/2.
There you go. So if he asks you that question, gives me the quantum numbers of the F type. There you go.
It's not my fault that
We got this, guys.
These are the F type quantum numbers.
Okay.
So if the S is an N4, the quantum number would be
4.
No. Craving sweets and I'm gonna have them.
3.
what's L?
It's gonna be 2.
What's L for S?
Okay.
0.
0.
0. So this L is 0, ML is 0.
ML is 0.
Here you go. You got plus or you got negative.
Got it. Yeah.
So if you actually like that, give me the S quantum numbers in N4. There you go.
Okay.
And that concludes this whole session.
Thank you so much.
Yeah.
All right. So if you forgot any more questions about the reviews, let me know. I can adjust it and stuff like that.
Okay. Thank you very much. You all have a good night.
You're welcome. Have a good night.
Good night.
Okay. Thank you.